Hi, my name is Monika Kuzma. I'm going to explain to you how to use our Q-Box RP1LP low-range respiration package. You're going to receive your Q-Box with everything already supplied. I propped this Q-Box up a little bit so people can see what's inside. But you open your Q-Box, there will be data cables that you connect the Q-Box to your computer. There will be a power supply that you need to plug into your AC outlet to power the Q-Box. You plug in your power supply. The power input goes on the side of the Q-Box. Right there. This is the tray with all of the analyzers. Initially, remove the tray out so you can check the plumbing and make sure everything is in order. There's two data interfaces at the bottom of the Q-Box to which the sensors are attached, and there's a temperature probe inside the Q-Box as well, which can be taken out and for measuring temperature either of your sample or the environment. So initially you're checking your plumbing. You have a gas pump which is delivering gas to the system. There is a small inline filter which prevents any particulates from getting into the system. It should always be attached to the input of the gas pump. Then you have output of the gas pump going into the flow monitor. The output from the flow monitor is going through a drying column before it enters the two gas analyzers. The gases measured by the CO2 and oxygen analyzer should be dry to prevent any dilution of the gases with water vapor. And we provide a drying column with dry right, which has a blue indicator that will turn pink when the dry right is spent. That gives you an indication when you need to change it. And we do supply in the kit some extra dry right, but this can also be regenerated in the oven. From the dry right column, the gas enters the CO2 analyzer, and then after the CO2 analyzer, it is carried to the oxygen analyzer, and then it vents out from the oxygen analyzer when the system is used in open flow mode. So the way that this is plumbed right now, it's set up for calibration. So you can place the system back inside the Q-Box and turn on all your sensors, including the pump, or the pump can be turned on a little bit later because initially we need to warm up the sensors, especially the CO2 analyzer requires at least 15 minutes to half an hour warm-up time. If you are using your Q-Box regularly, we recommend that you leave the CO2 analyzer powered at all times. It will maintain the calibration for a lot longer, and it works better when it is powered continuously. So the gas pump can be turned off, but the CO2 analyzer, oxygen analyzer can be left on. Oxygen doesn't matter, it can be turned off as well. The system comes with a kit that contains extra pieces of tubing. There's some extra dry right for the drying column. There's some blue Cubitac to use for sealing any leaks that may occur in your system, especially in the chamber. There are two animal chambers that come with this package. There's a large flow-through chamber and a small flow-through chamber, depending on the size of your animal. And in the other bag here, we have a little wrench that you need to adjust needle valves on the back of the flow monitor and the gas pump. There is a locking nut that has to be tightened after you've adjusted your flow rates, and you use this wrench for that. And there's a small screwdriver that is used during calibration for adjusting the CO2 0, CO2 span, oxygen 0, oxygen span, and it can be also used to adjust zero flow. And that's explained in the manual. Flow span should not be used unless you have a flow standard. And there's some extra connectors as well. We also provide manual valves to set up the system when you're doing your measurements of your sample, so you can easily switch between a reference and mode and the analysis mode. There's only one set of analyzers, so in order to measure reference or background levels of CO2 and oxygen, you need to measure the gas that is coming from your gas source, which will be either air or CO2 scrubbed air that you can place inside a gas bag, which is also provided with the system. There's 2 gas bags provided, and when these are filled with your gas, they would be attached here to your gas pump. If you don't use the gas bag, if you use tank air or some other gas from a tank that's provided under pressure, then you need to supply it to the gas pump via a T-piece. So there has to be some gas venting so you don't create high pressure situation when the gas is being delivered to a gas pump. So I'll just quickly go over how to hook up the system when you're doing measurements of your sample. So the gas pump outlet would be supplying gas to the valves, which are connected here, and then the output would be going to your flow monitor, and your chamber with your animal would be connected to these 2 outputs of the valves. When the valves are in the off position like this, that is when you're measuring your reference levels of gases. The gas will be flowing from the pump directly to the flow monitor. When these are turned into this position, the gas now is being carried into the chamber, through the chamber with your animal, and back out to the analyzer. So this is the analysis setup for measurement. So right now you're measuring gases that are being delivered directly from the chamber which contains the animal. So it's a manual way of switching between your reference and your analysis, and you need to know those levels in order to do your calculations of gas exchange. There are 2 chambers provided with the system, a small chamber and a large chamber that I've already gone over. And there's also a soda lime column provided. The soda lime column is used to scrub CO2 from the air. So when you are doing calibrations of the CO2 analyzer, it's a 2-point calibration. The CO2 analyzer is got a linear output. All you need is 2 points to calibrate it or to check the calibration. One is the 0 CO2, and that can be provided by supplying gas through the soda lime column. And you would do that by placing the soda lime column just in front of the CO2 analyzer. So right after the flow monitor. So you connect it to the flow monitor and then straight to the drying column. Make sure that the soda lime column stays in the upright position. And of course you would detach these 2 valves in your sample from the system for calibrations. So in this setup right now, when the pump is turned on, the gas is being carried from outside room air through the system, through the soda lime column, which will scrub any CO2 that's present in the air and bring the CO2 analyzer to your 0 position. You can see the readings are dropping right now. And when you do reach your 0 CO2, if the 0 is exactly 0 as it's shown on the display, then there's no need to do anything. If your 0 is not on the display exactly 0, you can adjust it using this little screwdriver by turning the potentiometer here in the counterclockwise direction to reduce and clockwise direction to increase the signal. So you would do that until you reach 0. If this value is quite high, this is a fine 0 control. You may have to go to a coarse 0 control, which is on the back of this instrument, and it's not visible right now, and it shouldn't be accessed unless it's absolutely required. And the manual explains how to adjust it. It's also a small screw that you use this screwdriver to adjust and reduce the 0. The second point in calibration for the CO2 analyzer will be a standard CO2 coming from a tank, for example, maybe 400, 500 parts per million, something in the range of what you're going to be measuring. You can fill this gas bag with your standard CO2 for calibration. If you do not have a standard gas tank, you could use outside air sampled from outside, not from the room where there's people, and supply it to the CO2 analyzer. Outside CO2 levels should be around 400 parts per million, and for teaching purposes, that's going to be good enough for calibrations. For an oxygen analyzer calibration, we recommend that you use pure nitrogen to obtain your zero oxygen, and pure nitrogen can be filled inside this bag again and supplied to the system. And for the second point in calibration, you can use outside room air, which is dry through this drying column. And we know that the outside room contains 20.95% oxygen. So that second reading can be obtained by just using outside air. So you really only need 2 gas tanks for calibration of your sensors. One standard CO2 gas tank, like for 100 or 500 parts per million, and one pure nitrogen tank to get the zero oxygen reading. Okay, we are now ready to proceed to the second step, which is downloading your software.